So this week, we're going to talk about chapter 5 in your textbook, which has to do with sections. And we're really going to focus primarily on the conventions that are described in chapter 5. So when you hear the word conventions, I want you to think of it as we're treating something differently than what you've learned to treat it so far. So, we've learned pretty well how to create top, front, right side views, put all the hidden lines where they belong, create full section views, half section views. We've done that. This time we're going to add some conventions, which means we're doing something different than what you normally should do. And this is where Inventor really struggles. So if you're starting to get your Inventor legs under you and you're thinking you're wanting to switch over to Inventor this week, I'd recommend switching later, because Inventor cannot do these conventions. Inventor is handcuffed to do what's real. So it makes a part, and if you cut that part along this line, your section view gets what you get. You can't fake it. You can dance around and do some fakes, but it's really a big dance and it's not worth the energy, especially when you can use AutoCAD and just do it, right? So we're going to talk about these conventions and section views. Just kind of a little review. When we talk about full sections, that means the cutting line goes all the way through the part. Everything projects lined up. Full sections usually replace one of your standard views, right? So, it should take the place of a front view or a top view or a right side view or something that's that oriented that way. Excuse me. If you're working on, like round parts or shaft type parts, and you create a cutting plane and you project your section view, and it looks like exactly the same shape as you put your cutting line in, you put your cutting line in the wrong view. Right? It should be the different shape than what you started with. Okay, so try to explain that. But we still have a cutting plane line represented by a plane. The section lines are where the material is actually cut, right? The cross hatch. Okay, they call it hatch. So we hatch in where the material is really at, right? And where there's no material, we don't have any hatch. Same thing over here, right? No hatch here, no hatch here, hatch here. Just that's normal, right? Inventor can do that great if you don't have to do any convention stuff. We label the views, so both ends of the cutting line will have a label. We'll start with A, and then we'll label the view, section AA. So the cutting line is labeled AA, and the section view is labeled section AA. If you have two, then the next one's B, C, so on and so forth. Don't start with C. Later on, when you start drawing an Inventor, if you make a section view and you think, oh crap, I didn't like that one, and you erase it, and you start all over, the next one you make is going to be B. And A is not going to be on your drawing anymore, but you can change it. Just be aware of that. It's going to advance as you make multiple section views, even if you erased them. So you have to go back and correct that. You can correct it, and it corrects fine, but just be aware of that. Your first section view should be A. There shouldn't be, if you have a drawing and you see a section C, in your mind, what are you thinking? Well, where's A and B, right? There should be more. So that's the natural thought process, and that's why we start with A. However, I taught I get off on a tangent. I taught a blueprint reading class for Danfoss up at Cersei. Used to be Eaton on some of their parts. They'll have a section view just starts out as like Q. No. So that was hard. That was hard to explain to the newbies looking at drawings for the first time. But yeah, so you may go to work somewhere and that's completely out the window. I was telling these guys about to graduate. When you go to work, you do what they tell you to do, not what Mr. Casey said. You might say, I thought we were supposed to do it this way. And they said, no, we're doing it this way. And then you just move on. Okay? Because they're the one paying you, not me, but telling you the way most people do it. All right. So we see the section lines. In some cases, this section line may represent a material. The pattern of the lines represents a certain material. You'll see a lot of this when you get into Revit. If you're doing your cross sections of your walls, you'll see one pattern for wood, one pattern for concrete blocks, one pattern for cast concrete, sand, all that stuff will have its own little symbol that represents that material. But a lot of times you may just see the general ANSI 31 single line 45, so it represents all materials. So that's kind of some of the stuff that's on the fence. ANSI 31 is kind of the general use. You'll see it for all materials, or you may see a specific material to the material. Just, and vendor, if you have your material set to aluminum and you crosshatch it, you're probably going to get the aluminum crosshatch. It just depends on what that material you have selected in the materials of that part. So we want to try to avoid having the section lines parallel and perpendicular to your primary edges of the part, because that adds confusion. What's a section line? What's a real edge? So generally they're on a 45-degree angle. If your edges of your part are on a 45-degree angle, you might, jostle that to 60 or something, tweak it a little bit just to kind of get it so it doesn't stand out and confuses the edges of the part. So
it's always going to, we click on the same crosshatch, it's always going to be a 45.
By default, it's going to be 45.
45.
Yes, if your edges are 45 degrees, then you may want to adjust that angle some so that you see the difference. Not, how much is kind of arbitrary to where you can feel comfortable. Yes. So instead of, if you were making something using this general purpose and this was your outside shape, you wouldn't want those lines like that. Maybe you adjust it to run like this. Right. And you have control of that. In all the packages, you can adjust that. So full section, again, we're going all the way through. Notice how the full section here has replaced the front view in that set of drawings. So we have top, front, right side. Now we got a top section AA and a right side view. And in this case, I think you'd be warranted maybe to not include the right side view. It's really not buying us anything new. But notice how the section view has replaced the front view. I should probably click before I talk, but anyway. Another thing to remind you is when we create section views, there are no hidden lines. No hidden lines. We're not worried about anything going on beyond the surface that we're cutting. All of our concern is just along that line. The only thing we're concerned with is where that cutting line is going. So that's all that matters.
So in the book,
yep.
Not according to Mr. Casey apparently, but in the book, it does make a statement of hidden lines or a no-go unless they add to the understanding of the part. So how hard is that rule? So I want you to leave here wanting to not put hidden lines in your drawing views. Okay. And you go and you submit a section view for review when you go to work and your manager says, we want to show some hidden lines here. You put the hidden lines here. I mean, really, it's that simple. I want for the stuff that you're going to turn into me, unless there's a specific note saying, in this section view include hidden lines, no hidden lines. And I don't think I don't think I have that note in any assignments. So. I didn't mean that in disrespect. Oh, I understand what you're saying. And that really, that rule applies to everything I'm telling you. For the most part, this is the way everybody does it, but everybody does things differently. They may be ISO 9000 certified and have every standard labeled out and everything they do, but they may do something a little different still yet. And then that's who we ultimately have to make happy. I want you to think of me as your manager right now, and that's the way I want it. When you land that gig, you got a new manager, and he may want things a little differently, but you're going to know the fundamentals and the way things normally are done. And it's not, I don't have anybody, of all these years I've been doing it, I haven't gotten anybody that came back and said, I really didn't know what the devil I was doing. I really couldn't. There's been a handful of students repeat a lot of classes and eventually get a degree that probably still don't know what they're doing. But I've never had a student come back that worked in the field for a while and say, I wasn't prepared, and here's why. If you are that person, I would love to hear that story, and I'll try to do things differently. But so far, everybody's happy, and the people that hire our graduates are standing at the door wanting more of them. So they're happy too. So half sections, we're talking about halves. So, a quarter of the part is actually removed when it's a half section, and only half of the drawing view is shown in section. Notice there's no hidden lines in that part. That's still normal. We still don't show hidden lines in that part. And
In our book from last semester, you may remember these may have had, I saw some of these lines kind of weirded out with arrows going this way. That's really not the way it should be. It should be like this one shown here. Our arrow is pointing in the direction that we're looking to derive that section view. We're looking from this direction, looking that direction, and this is what we see. So these half sections really should only have one arrow, not a zigzag other kind of weird arrow. But I did see that in the book from that engineering graphics class. So now here you may have what's called an offset section where the cutting line does kind of zigzag, but it's zigzagging to go through specific features so that you can show those details in the section view. So we're trying to show what this counterbore hole, what this tapered hole, and what this plain hole looks like. And that sectional view will replace that non-section front view. Should. And notice where the section view changes direction. You know, here it turns and goes forward this way. So you might be inclined to put a line right here, but there's really not. There's no edge there. So don't include that. Revolved sections or removed sections, those are intended to show the shapes of stock. You know, if you look at those two at the top, that front view looks exactly the same, whether it's a round bar or a rectangular bar or a triangular bar, right? That view, this primary view here looks exactly the same, regardless of what shape it really is. You know, if this part was actually stopping right here, it wouldn't have, it's pretty rare you see those curves on something that's truly just that long. It's just a rectangle. You'll usually see those break curves if the part is broken to save space on the paper. And that helps you see that it's round. But in reality, this revolved section view is showing you the profile of that bar. So in this case, it's round. In this case, it's triangular. It could be rectangular, right? Square. So that's called a revolved section where it's superimposed into the profile. It's just cut, turned 90 degrees and dropped right there inside the profile. Just helps you understand what the shape of that part really is. This is called a removed view. So we actually broken about, it's doing the same thing, but we just kind of break the main part away to show it. You might see it in both these ways here, this one or that one. When you have these revolved sections, this edge should not be in there. It should look like this. No edge there. Because if you cut that and look at it, there's no edge when you cut that and look at it from the end. So just make sure you attribute to that. Let's see. Like I said, I should click before I go through that. We pull these sections out. You know, we're following the labels. This one, AA, section AA, BB, B, C. So, you know, we create those section views. And again, we're only concerned with what's happening right along those sections. So that's why you're not seeing the rest of it back here in those views. We might have a broken out section. So I use this a lot of times when I really don't want to create a full section view just to show one little detail. You know, maybe I've got all my dimensions done. I really don't want to start all over. So I say, oh crap, I forgot to detail this little hole. Or a lot of times it might be a keyway, you know, in a shaft or something like that. You can do this broken out section. When you do a broken out section, I really want you to try to focus on making this really zigzag. So it's not, nobody's going to confuse it as part of an edge of the part. And when you do this in AutoCAD, you don't need to draw this stuff up here. I did that out of habit. If you're doing it in Inventor, then your sketch needs to be a fully closed loop. If you do it in Inventor or SolidWorks, your sketch will have to be a fully closed loop. In Inventor, you would use like a spline and make these zigzags so it's nice and curvy and got a lot of, you know, don't be afraid to click a lot to make this zigzag, really zigzag. So what we're doing in this broken out view is we're just kind of peeling back the material a certain depth until we can see what we want to see. In this case, that counter bore hole. Let me click the words up here. I may have not said something I was supposed to.
You have a question, I know. I can see it on your face.
So, so the section view is just that little.
Yeah,
piece, really.
right.
This is
a regular front view. Yeah.
just like normal.
Yeah.
And so we're putting a section view in this case in the drawing that we've already done.
Yeah, we're just peeling back a little bit of material to show one specific feature on a part. Instead of making a whole section view, you could have just as easily did a full section view here or a half section even, right? And section the whole thing. When you get into like Inventor and SolidWorks and you've gotten this far in and you forgot to detail this little keyway, there's no way to do it without a section view, right? So this breakout section view a lot of times is just a savior to keep me from having to redimension everything. So I got this view already. Maybe this part started without that hole and you've got a revision to add the hole. Instead of having to redo the whole view, you can just pull it out, cut that hole out, add the details there. Broken out sections, pretty handy. Most of the time I see it on key seats for shafts. That's the most common place you see it. For me, if I had this counter bore hole, instead of being, I would probably change this orientation a little bit. I would probably rotate that right view 90 degrees. So I'm looking straight down into the plan view of the counter bore hole, and I would just give it a counter bore note. Probably wouldn't section view it if it's a counter bore. That's a plain hole.
What's a key seat?
So a key seat, that's a good question, and we'll get to it maybe a little later. But if you could visualize an electric motor, maybe that's turning a pulley, right? So the pulley has a hub that the shaft goes through, and the hub has usually a little rectangular notch for a keyway, right? The shaft has a slot in it for a key to set in. So a key is a little extra piece of material that sets down into a slot on the shaft, pulley slides over it, and it lets that shaft transmit that rotational motor to that energy to the pulley. So you find keys on things that rotate. Your lawnmower flywheel has probably a Pratt and Whitney key that has the shape on it, and they're aluminum. And when your kids hit the cypress knees or the cypress tree you stupidly got in your yard, it shears that pin instead of wrecking the whole engine, supposedly. But we will look at some key seats. In fact, I've got some details in Canvas. I can show you what we're talking about. But a keyway is in a hub that slides onto a shaft, and a key seat is in a shaft. So the key sets in the seat and slides through the hub. So anyway, we will look at those a little bit later. But we don't have to label anything. It's just everybody can understand that we pulled that material back. We got our crosshatch, shows the material, and we can do our detailing there, whatever dimensions we need to add. When we have assemblies, and again, this is all just kind of review, I think, from the stuff we talked about last time. When we have assemblies, notice that the shaft is truly being cut by the section view, but it's not crosshatched. So shafts are not crosshatched. Fasteners are not crosshatched. So we've got a washer and a nut. We got probably a bushing or spacer of some sort. We got a taper pin. So here's that key, right? So this is a key. And in this part, right here is the hub, right? And there's a little groove. If we look at that from the end, it kind of, my sketching in this stuff's not real great, but it'll look like that, right? The hole in this piece, right? And then this down here is the key seat. So if we cross hatch right there, we cut this and look at it, the shaft down here will look like that. And the key fits down in there. It's not quite that big and slides inside here. It holds all that, transfers that rotational motion. Does that help? Justice, does that make sense? Keys. Because I got these guys about to graduate and their last project had a key in it. I'm like, what is a key? I'm like, oh dear, we messed up somewhere. Anyway, there's a wide variety of keys, and hopefully we'll get to that. Notice that the parts that are adjacent to one another, the crosshatch is rotated 90 degrees. or maybe 180 degrees. You know, it's opposite to help you distinguish one part from the other.
The bolt's not cut at all.
Right. So the threads, I think, here is actually part of the shaft. So it's just the end of the shaft is threaded. But yeah, none of the shaft is threaded. The nut or crosshatched washer, these bushings, this taper pin, all those are not crosshatched fasteners.
Hidden lines on a taper pin.
We're not talking about
Oh, that's a good question. So you are seeing some hidden lines. And the hidden lines that you're seeing have to do with the key seat and the taper pin. So if I were grading this, I would probably not. They're either going to have to be hidden lines or solid lines. I mean, you would see that if you were cutting it right down the center, you'd actually see edges, you know, same way here. So I don't know. There are hidden lines in there. That might be one of those cases where I'd make a special note if I were asking you to do something like this. Conventional brakes. If you have something that's round, you'll see these curves, and you may see it crosshatched like this or not. You may see it both ways. If it's tubular, you can kind of see that this one's hollow, a little different. Rectangles, you might see it done a variety of ways. Just a curved brake like this or a triangular brake like this. Even if it's short, you may see it both ways. You may just revolve the sections here for those. The ideal of those brakes are just to kind of help give the reader of the drawing an idea of the shape of that profile. What's going on with the ends there. And it also lets you put long things on regular size sheets without having to go really down in scale. What's really the downside of going to a really super small scale? Does anybody know? Why not just make everything on A size and just scale it?
Because if a big part has small details, then you're shrinking down like something that would.
Yeah.
I mean, I guess, for example, if it was on a D size, that's huge. And then you're scaling that all down so much smaller. It's going to be hard to see everything.
Yeah, the consequences of using really scaled down drawing views is crowded and unneat. So the rule of thumb is use a big, full size or bigger if possible. That's especially since I'm old and I have a hard time seeing stuff. And as you start to dimension, if you've got a drawing on an A size sheet that's 1:4 that would really fit 1:1 on a B size sheet, when you start placing your dimensions, they're really crowded and it's very hard to make it look easy to read. And that's kind of your clue. It's like, crap, I shouldn't do that at this scale. Let me rethink this. For our work, B size on parts is usually pretty good. If you wanted to do something, if we got something really tiny and you want to do it 4:1, if it's on A size, that's fine. I'm not saying never use A size, but I do have some students that just get stuck using A size all the time, and no matter what scale they have to do, and it's really hard to get the dimensions to look neat. They're simply too crowded. So 1:1 is ideal regardless of sheet size. Go up. I don't care if you use C or D size sheets. I'm not printing them for the most part, so it's fine. We can print now. We have 2 new plotters, so there was a year or so where it was like kind of iffy if we could print. Yeah, everything had to line up just right, but we can print right now. So take advantage of it if you want to. If you want to print something, take home, hang on the refrigerator, be my guest. All right, here's where we get to the stuff that people go crazy about. Yeah, this is where. And this is what we're trying to focus some energy on, is we're really wanting to apply these conventions. So here we have this round disc on the left. This round disc, maybe it's got 4 holes, okay? And we got our cutting line that goes through 2 of those holes. Our section view down there looks right. We got 2 holes in the section view. Everything's all happy, right? Inventor could do this fine if it did have 4 holes and your cutting line went through 4 holes. But if we go to that middle one, so this middle one, the disc only has 3 holes, not 4, 3. It has this one,
this one, and this one. Those are what's really there. Okay. Your cutting line goes right through here, right? So technically this hole should not be there based on what I've taught you up to this point. And if you were to model this inventor and put that section line there, it ain't going to have a hole there, right? But the conventional way to show this is to rotate this hole to the cutting line and include it in the section view.
Then why wouldn't you just make the cutting line go from the center point of that feature through the circle? Wouldn't that be the exact same thing you're saying?
For an inventor, that might get you the same thing if you had to do an inventor. But here's the thing, it's the conventional way to do it. So all these years of people practicing drafting, this is what they do. And this is why when you look at a part and you see the three holes, you won't have, in the top view, this hole won't show up right there. It won't be there. It'll have this one. You know, it'll have what's really there in the top view, but your cutting line goes all the way through. And this is what your section view is going to look like. So if you see that, that's what's going on. It's they're following that convention of revolving that hole to the cutting line.
Is there any notation saying that's what's?
No, no,
No.
you just know that. So when you look at something like this and you start scratching your head, wondering what's going on here, that's what's going on. It's this convention, and this very same convention not only applies to holes, but it applies to ribs and spokes and mounting lugs and different things. Okay. So, you know, just understand we're taking that one hole and we're theoretically revolving it down to the cutting line and we're including it in our section view. That's what's happening. You know, 4 holes, everything's just fine. We're all happy. 3 holes, we take that one hole down. Maybe there's 6 holes and maybe we're going back through it, or, you know, maybe there's 4 and only one of them's hitting. We're still revolving that other one to the cutting line and showing it down here.
Okay, I can read that now. But it's got 4 holes and you're moving.
Yeah. I think that's what's happening.
I'm with that.
That's just so.
Yeah.
Like.
I wish I had a good argument to that being so like, but I don't. I don't. But the same thing happens with ribs. Okay. So this first one on the left, we got 4 ribs. We section it. We see our section view. And the only thing really different with this one is that those ribs are not cross-hatched. They're actually material there. So by all means, it should be hatched, right? Because there's really material there. But the convention is that you don't cross-hatch ribs. Inventor cannot do this. Inventor has to cross-hatch those ribs. There's a big dance that you can do to turn things off, and sketch things in and make it not do that, but it's a big problem. So, SolidWorks, if you model that as a rib feature, it knows not to hatch it. It can do this convention. Yeah, Justice. I think that's just to kind of help you realize that one was truly projected over there. It won't look any different in your drawing. That's a good catch, but you're talking about in the section EE there, that rib on the right side's kind of got a light gray. I think the thought process behind that picture is that that's showing you that rib's really not there, but you're going to project it onto there. But you won't have to do anything different to make it look that way on your drawing. But that's what's happening. So that second one only has 3 ribs. The cutting line does not pass through the one on the right, but we rotate it down to the cutting line and draw it just like it was. So if you were to actually like create this section view in Inventor, this one would kind of come in, probably look something like that. So it's going to project, you know, it'll project this line down here, wherever it hit, you know, about right in there. It's going to look short, you know, short. That's not the convention. Again, just like that hole. And if there was a hole and ribs, they're both are going to follow the convention, right?
Even if they're offset.
So if this had, it's hard to say.
Trying to think where the hole. So if this one had a hole right here and a hole right here and a hole right here, we would see two holes down here. Just like that, no crosshatch. Because this one rotates this way, right? And this rib rotates this way, and everything's on the cutting line. And I wish I could answer your question and say, why is that? A lot of times, a lot of these conventions come from the days when people had to do all this work with a pencil. So you're really trying to not have to do as much work. It's where a lot of these conventions come from. I really, I think the thought process is looking at this shape that looks like this is easier to understand than if it looked like that. I think that's really as far as these ribs.
I was about to say something like, how is that easier if you don't have to draw the feature?
Yeah.
But then you pointed out that in this case, you would have to.
Yeah.
still
Yeah.
draw that
Yeah.
feature.
And it would look a little weird, right?
Yeah.
But I mean, it seems right, even though it looks weird. But this is that convention. I'm trying to tell you, hey, buddy, this is different. This is what we're studying this week. So apply this. I get a lot of these drawings come back to me, just like we never talked about this. So you guys are all listening to me, so I appreciate that. So I'm not expecting any bad drawings out of you guys. So here we got spokes in a wheel, just like ribs. So that first one on the left, just like everything, the cutting line goes through both those goes through two of those four spokes. The section view down there looks fine. The spokes are not cross-hatched, just like a rib. Inventor can't do that. SolidWorks can't do that. If it's a spoke, if it's a rectangular, depending on how you might can make it as a rib and it not, but it might be challenging. The middle one's got three, just like all the other examples. It's got three spokes. The one spoke is rotated down to the cutting line. Same kind of thing. So the cross sections look exactly the same as the wheel with four spokes.
New place to sit on. Like they did here.
What's that now? You talking about the hole, through the hole?
On the section view, yeah.
Yeah,
So,
yeah.
we
So
need to do that.
yes. So that's a good point. Go ahead.
On this one with the, rectangle,
Uh-huh.
why do it show the, center of these four when it didn't show it on the first one on the whole?
Let's see. So let's back up. Yeah, so you're talking about the center. I would personally probably like to see the center axis on all these, as well as this one.
Right.
Yeah, I can't really talk about these images on the slide, why they're like that. I would like to see center lines in them. So anytime you have a hole or a circular material that has an axis through it, I'd like to see the center lines, whether it's solid or as a hole. Good question. So we got the four spokes on the right, three spokes in the center, and then we got six spokes on the right side. So, and all the section views look the same, regardless of what's going on. Yeah. So are those spokes rectangular or are they round?
Well, actually, the spokes are round.
Well, and you really can't tell, but I think they're rectangular. If they were round, if you look at the width of it from the top and the thickness of it in the section view, they'd have to be the same. And I think they're a little thinner in the section view. So I think it has to be a rectangle, but that'd be good to know, right? I want to put a revolve section in one of those other ones just to kind of help somebody out. All right, so here we have some mounting lugs. Same thing is happening with these mounting lugs. So it's all the same philosophy and thought process. You just got to apply it to holes, ribs, spokes, mounting lugs. So same thing here. On the left, we got four. Cutting line goes through them. The section view is pretty much what you would think, except a couple of things. The lugs don't have any cross hatching, even though they're material being cut by the cutting line. And we've also got those hidden lines for the holes. I guess to help you know there's a hole there.
But if you cut it,
should be an object line.
Okay, it's making me think a lot that these cutting lines never go through these features. And
Oh, it's just
you've
like,
been taught wrong all along.
well, yeah, maybe we should start explaining it like that. This cutting line is really not going through that. You just project it like normal, right?
Yeah, it's too much work to just make this cutting line go up here.
Yeah,
Like they
yeah.
have in some other sections.
Mhm.
They've just decided to not make it go around
But I
this
can see,
feature.
I can see as for the section itself, that is kind of tilted, whereas the cutting line that actually goes through here.
Oh, yeah, like,
And that would put all these on the same planes to put those big lines.
yeah, I kind of mentioned that a while ago. Like if we were to take this cutting line here and you go from here up like
Right.
that, yeah. And that's what you may have to do in a solid mauling package. And notice this one down here, Justice, is gray, kind of like that rib was a while ago. And I think that's just kind of helping us understand. I think that's just trying to help us understand that that one's the one that's revolved down onto the cutting line. But in your drawings, it'll look exactly the same as the other side.
So when we draw this out, I don't know what we have to do, but say we had loads to draw.
Yeah.
Do you want hidden lines or do you want object lines?
So I think,
But yeah, they go from here to much better job.
unless I specifically say something otherwise, those would probably be object lines.
So we are gonna cut through the feature, unlike what they.
Yeah.
It makes more sense to do object for cutting.
Right.
It makes more sense to cut through what you're cutting.
Right.
Watch it like you should, right? Yeah, like I said, I wish I really had a good argument to justify this. I don't, but let's talk about the projects for this week and then